So, moin zusammen. Wir sind 25, warten noch einen Moment. Frohes Neues an alle. Und dann schauen wir mal, wenn wir einigermaßen Leute zusammen haben, dann fangen wir an. Okay, 2 minutes past starting time. Let's get ready. Welcome to our first Distributed Information Systems lecture in 2022. Online again, and for the rest of the semester. And presumably our exam will also be online, so business as usual. Regarding this week, we will meet again on Thursday, and on Thursday we have an external visitor, and this therefore leads to the problem that we have to use a different meeting link. So I will send this meeting link inside the chat channel on Thursday, and then you have to use that link to come to the meeting. Otherwise, our external visitor, she couldn't join us. So that needs to be taken into account. We will continue with the stuff we left over last year. I postponed the upload of the second exercise to the end of today. So you have still, if you have still questions regarding the last exercise, you will be able to ask them in the exercises today. And but the goal is to already have finished that and start with the new exercise today. And if you are able to start today, you should be right on track regarding the exercise solution. So you should be able to finish with all the exercises with the end of next week. Anything else I wanted to say? Can't really remember. Perhaps it comes to my mind at some point. So let's move you to the side screen. Then share some screen. Which screen to share? I think I will use this one. Of course, Teams minimizes. Why that is the case, who never knows. Back to the main screen. So let's see. Come on. So now you should be able to see my slides, hopefully. And as far as I remember, this is where we left. So we talked about the deployment of the Servlet web archive in order to get a Servlet up and running. And this should be working for all of you, hopefully. And basically, if you already did your exercises, you should have read the following slides already. Otherwise, you would have had problems solving the exercise. But of course, Google always is your friend. So one part of the exercise was to extract some parameters from the URL. And so it was the exercise. Oh, any question or just some microphone not muted, Herr Hofstetter?
Oh, sorry.
Yeah, okay. So the exercise was to grab some parameters from the environment, and there are multiple ways to provide some information to the servlet that is up and running. So you can extract parameters that are available inside the servlet container, or that have been defined inside the servlet container. You can access parameters that have been integrated based on annotations, or in the old days due to the deployment descriptor. You can access parameters that are provided inside the URL or inside a form. That you can access those. You can access parameters that are inside the HTTP request, another aspect, and of course you can access the client ID if it is provided. Basically, that is the idea. And in order to get your hands on the exercise aspects, you would have to use the get parameter, respectively get parameter values inside the servlet, and the servlet request class should be used on that. And then you should be able to access all the parameters that are necessary to solve the exercise. One important
when extracting the client, the user agent, is it normal that there is always Safari in the string at the end?
Yeah, that's basically always provided.
Okay. And what has it something to do with the Safari browser of macOS, or is it an old artifact?
I'm not sure why it's always stated. Perhaps it's the engine that is running in the background that is also used in that is shared over the different browser types, and therefore the content is provided. But I haven't looked it up yet myself, so it's basically I'm not really interested in that at that point. The client is not so interesting. It's more like, okay, what's the server technology in the background? Because then that is an attack vector for people who want to attack your system. So the knowledge what a web system is, or what a servlet engine, what a no, I now dropped it. What a web server is running in the background is more important, that you can manipulate that in order to hide the information, and therefore don't let the attackers know what system is running in the background. Mr. Steiner.
Okay, thank you.
Okay. So another important aspect that needs to be taken into account is the so-called client state. As you may know, the HTTP is a stateless protocol. So basically, you don't know which client is currently doing the HTTP request. And that, of course, is a problem if you have one only communicating with one client, no problem at all. But what happens if you're communicating with thousands of clients? And then, of course, it would be nice to know which client has issued which request before the current request, so you can distinguish the clients. And therefore, the client state is something that is of importance, but which is not supported by the protocol itself. So we have to come up with solutions to cope with this problem. And there are three basic approaches to tackle the problem. Basically, we all know the cookies, especially based on the new privacy laws. Every website has to state that they want to drop some cookies on your browser, and so this is a quite common approach. Nevertheless, if cookies are not supported, we can use URL rewriting if we wanted to. So every link we follow inside a web page we provide, it has a specific attachment, a URL parameter, which we can use to identify the ID of the client. And of course, we could use hidden fields inside our replies and therefore store some content inside some forms. So we have the ability to use either one of those, or we can use them all together using the HTTP session, which chooses what element we want to use later on. So that's basically the idea. As you should have solved all the exercises already, we try to do this in a rather quick manner. So we all know cookies. It's a rather simple API. Some information is dropped at the client side. Typically, it's some kind of ID that makes you identifiable. And that is something that you could use. One thing that should never be done, never put anything security relevant in a cookie, because it's plain text stuff, and therefore this shouldn't be done. Of course, there is a cookie class that is available on the programming side. You can get the name of the cookie and the value of the cookie that you dropped inside it. You can set a specific maximum age so that the browser is able to get rid of your cookie at some point. You can set some comments. And this is a small text fragment, a program fragment that gives you an overview how this cookie could be used in some kind of way. But it's just something that needs to be taken into account. The second one was URL rewriting. So every URL in the response side gets a specific attachment. Basically, or typically, it's a JSession ID attribute. And the advantage of this is that this cannot be deactivated. You can tell the browser to ignore cookies, but you cannot tell the browser to ignore URL parameters, so URL rewriting. So this is a very simple and always working mechanism. The disadvantage is, of course, that all URLs inside the response side must be manipulated. So you have to encode the URL you want to integrate into your response side with the session ID. And the session ID is only available if you query the session ID beforehand. So even so, you're not using the session object here, you have to request the session object so that there is really a session ID available. Otherwise, it will just return a blank or an unmanipulated URL at this point here. Yeah, that's basically one thing. Of course, this is restricted to get codes and brings problems with bookmarks, but nothing is perfect. And we have the hidden fields that can also be provided and or can also be used when you provide a form, that there is a specific hidden field that contains the value and is then returned with the next triggering of your web application. As I said, you can either choose of one of those three, or you can use the HTTP session object, which tries to solve all the problems in the background. And that's basically one idea. And what you should experiment with at in at least one of the exercises, as far as I remember. So, and that's basically using the HTTP session object, which has the ability to use multiple attributes that you can. So it's not like a cookie where you have one value that you can store. You can have multiple values inside the HTTP session object. And you can check its creation time, ID, last access time, and everything else. So it's quite powerful, and it gives you the ability to store the ID of the client, and therefore store the client ID and the session inside the HTTP communication. And this is quite nice. And typically it is needed. What follows then are quite a few attachments. The thing with the attachment is that it might be interesting for one or two of you, but is not relevant for the exam. So it's just background information. And therefore, I didn't translate it into English. So it's still in German most of the time. So it's something about annotations that are available and communications between servlets. So the ability of servlets to communicate with each other based on their name tag. So we already saw in the servlet annotations that you can provide a servlet, can give a servlet a name. And this is used if you want to have servlets communicating with other servlets. So the idea is a browser issues a request targeting servlet A. Servlet A does something, forwards the request to servlet B. B forwards it to servlet C, and servlet C then sends the response to the caller. And the idea, of course, is again, you have a big problem and don't want to solve everything into one big class. So you split up the stuff into multiple different servlets that use each other in order to solve the task. That is possible. And there are some code fragments that show you that. Then you can also do some asynchronous communication with servlets, but this will lead us too far away. So the thing is, all the attachment stuff is just background information for the exercise and the exam. We are staying on the side before the attachment. So it's just some background information, and that the thing that we are already done with this part. And this brings us to the next topic. And as there are quite a few slides available in this topic, I will not, or at least we can shortly take a look at the, on the next exercise. And the next exercise, exercise sheet 3, is about JAX-B. That's a mechanism transforming Java objects into a serialization format, XML or JSON. This is quite nice. You will find out later in your programming life. And when we've tackled that problem, we talk about web services, the SOAP world and the REST world, and we'll do some exercises on that. So, and we start with JAX-B, and the problem with JAX-B is in the ages where we were below JDK 11, most of the stuff was in the JDK, was integrated into the JDK. So the JDK was stuffed with lots of interesting APIs. And then they realized, okay, this is getting too big. This is getting out of hand. The Java standard package is evolving and becoming too huge for most use cases. And so they reduce the content of the JDK enormously, and all the interesting packages, which we in this exercise want to use gotten extracted from the typical JDK. This, of course, brings us to the problem that we have to integrate them manually. And one of the biggest problem in this exercise typically was finding the suitable jars in the different repositories available, and especially the problem combining the right ones with the right versions. And this typically costed us lots of hours. And with the beginning of the Corona pandemic, I got rid of this problem by providing the necessary jars to you in the Moodle platform. So you don't have this problem of looking up all the necessary jars anymore. All you need to do is take a look at the Moodle platform, where you already found the lecture slides and the exercises and the upload of the exercises. And under the third entry stuff, there are the JAX-B jars. So these are the jars, external jars you need to import when you do the third exercise sheet. So this is the JAX-B jars. These are the JAX-WS, which are the SOAP-based web services, and the JAX-RS, which are the REST-based web service jars. So in order to tackle the first exercise, we need these jars. The second exercise, we need these jars. And the third exercise, we need these jars. And when you import those, everything should be running smooth. Nevertheless, you're of course invited to try to find a different combination of external jars to solve the problem, but the provided ones should work. So this is the idea, and therefore we have typical before task 3.1, we have different jars we need to take into account, and as we are all having different JDK versions, this makes my life a little bit more complicated. We have different exercises. So 3.1a is you have to pass the XML fragment provided here using the string class and substring, cutting the string into pieces, which is a way how it should never be done. Nevertheless, some of you with less programming experience tend to use this approach, and you shouldn't. But nevertheless, we try and do that. The next approach is how it is typically done by using a parser, a so-called parser, which is a piece of code which understands the grammar of the text and is able to cut it into useful pieces. And in this exercise, you should use a stream-based parser to extract the information so that the wind speed is 15.25 and that the wind direction is 225 degrees. So this is the idea. So you have something that is enclosed, some information that is enclosed inside some textual format. And the idea is to get the information out of this text format. And so we have the version we shouldn't use with cutting the string. Then we have the approach using a parser, which is a decent approach, can be used and it's okay. And the 3.1c is the most elegant approach, which in the background also uses a parser, but we don't see that anymore because everything is done fully automatically. So what we have is a Java object that has all the content and that automatically transforms this object, if we have it in our code, into XML or JSON and backwards again. And this, of course, is the most elegant approach because you only have to call a few methods and then fully automatically the object is transformed into XML or JSON. And you can use this XML or JSON, communicate it to some other place, and at the other place, the receiver can use this JSON and deserialize it again and build an object out of it. And of course, this is the best approach because you don't have to worry about anything if the content is stated syntactically correct. And this is the third exercise. So C is the most elegant approach we can use, and we practice that with a pet class, and we fill the pet class with some content, and then there are some restrictions which need to be taken into account when we serialize it to XML. And then you try to serialize an object that has this content into XML and deserialize it again back into a Java object. Check if they are both still have the same content. If they have the same content, everything is fine. And when this works with XML, you try it with JSON. And then you can see, okay, this works in both worlds, XML and JSON. And then there is a small optional part where you can use something that is not 100% syntactically correct, but nevertheless can pass it. And task 3.2 is then using SOAP-based web services. But I think today we will only talk about the content of 3.1 JXP because it's so much content. And therefore, on Thursday, we talk about SOAP-based web services. Oops, what did I do now? Let's do it this way. So let's see, I need this laser pointer again. What's the next topic is playing around with XML, JSON, and JXP. And the motivation to do something like that is because we want to use web services as our next server technology, client-server communication technology in our exercise. So we had sockets, we had RMI, remote method invocation, and now we want to use web services, which sometimes, and depending on which web service technology you use, more like remote procedure calls. So the other thing that is the procedural equivalent to remote method invocations. This is what we want to use and do. And in order to do something like that, let's first take a look at the definition, what a web service is based on the W3C. So what is a web service? And there's a typo still in there. A web service is a software system designed to support interoperable machine-to-machine interaction over a network. So the big thing about these web services was and is that, especially in the world of SOAP-based web services, that a program, a web server, an application can communicate to a machine without previous knowledge of the communication protocol, or without having or being attached to a different other server by a programmer. And that's quite nice. So all the machine needs to know, okay, this is the address, then it knows I can access the interface description in a known format, basically in a WSDL, VSDL description, web service description language format. And then it can read this description and build, based on this description, can build an interface that is capable of communicating with the backend. So all it needs to know is where it can get this WSDL file or information, and then can automatically construct this stub, this client stub, and communicate with the backend without any interaction of a programmer or an administrator. And this, of course, is quite attractive to build systems that are capable of interacting with each other. And that's basically the idea of the web services, at least from the SOAP perspective. So the idea is to enable web-based remote procedure calls that can be automatically constructed during runtime. This, of course, is quite attractive. And typical example is that you have a travel service, and the travel service communicates with different hotel services, flight booking services, and cars or rental car services. And this mechanism can be used. So the idea is that these two establish communication based on web service technology. This brings us to what are the two types of web service technologies, SOAP-based and REST-based. And when we take a look at both worlds, we see, okay, SOAP-based is slightly more complicated than the REST-based web services because we have more technology aspects involved. That's basically due to the remote procedure call feeling of SOAP, whereas REST-based is more data specific. So, and in SOAP, we typically use XML as a background technology to formalize all the information necessary. Then we need something that is called the Simple Object Access Protocol, SOAP, which is the naming factor for the SOAP-based web services. The WSDL, the Web Service Description Language, and maybe, if necessary, the Universal Description Discovery and Integration. But typically, this is only relevant for big companies. And so in our situation, we stick to the WSDL and SOAP to work on that field. And on the REST world, we have XML and JSON that are typically used to do the communication, or to do the communication based on the HTTP protocol, which is typically also true for SOAP. And the HTTP protocol, of course, is based on sockets. And so we experimented with everything on that side. Right. So SOAP-based, REST-based, all both have XML and JSON, or at least XML and sometimes JSON involved. And that's the reason why we first, of course, take a look at XML and JSON. And in that workflow, we also talk about the JXP stuff. So this brings us to XML. The motivation I already stated. We have some kind of information, person, birth date, social security number, address, and we have this information stored in some kind of class on the computer A, which is a Java-based program. And we want to communicate this information to a different other computer, which is C++ based, and should take the same content. And one way to do that is, as we already heard in one of the lectures last year, to transform this information into a transport format that can be interpreted and correctly read on the receiving side. And this can be done with XML, for instance, or it can be done with JSON, or you can use programming related other elements or different other versions. But XML and JSON are the most commonly used ones. And XML is an acronym for Extensible Markup Language, which is quite old already, because it was heavily used in the 90s and during the century change. And it has a method to describe and exchange structured data independent of the application provider or hardware. And the nice thing of XML is that it is readable for humans and machines alike. It is important that it has a tree structure, but we talk about that later on. So the good thing about XML and also JSON is that you can read the documents, which is quite important. It has a strict syntax, and the grammar, and based on the content, it has, of course, some kinds of semantics. So the content stands for something. And yeah, it's freely interchangeable between systems and platforms, and that makes it very attractive to exchange data with. So as it is already in use for quite a few years, so at least 2 decades, 2.5 decades, 3 decades, there are many tools, and it is widely used all over the industry. Those of you who have also visited the Android course know that XML is quite heavily used in Android development, and all over the place there are different formats that are defined in XML and used in that behalf. And XML looks like this. If you never saw something like that looks like XML, so it looks similar to HTML, but it has a slight different meaning. So what's the structure of a typical XML document? We have an XML declaration, which is optional for version 1.0 and mandatory for 1.1. But in our situation, we can often forget the header declaration. But of course, if you want it to be syntactically 100% correct, you should state a XML declaration. And then we have the XML data body, which needs to be provided. Right, so the XML declaration is optional in version 1.0 and mandatory in 1.1. And it's always, or in most of the times, provided at the beginning of an XML document. If there are additional attributes like encoding and standalone, which can be dropped, but if they are provided, the order is important. So first encoding and standalone. Right, some explanations about the available attributes, which are not really relevant for us. More relevant for us is, of course, the content area, the data area, where we store the important aspects, the aspects we want to communicate, and which is also part of the exercise. As XML is always a tree, the data area needs or must have one root element. This is a syntactical must. There must be one root element. So register here is the root element, and there is only one root, and therefore, as the structure is a tree. Inside this root element, there can be different branches, so title is more like a leaf because there is not another element inside title. Entry, for instance, could be seen as a branch because entry also has some sub-elements, keyword and entry text, and therefore entry could be seen as some kind of branch, whereas title is some kind of leaf. And what you can also see are the different aspects that can be provided, how an element can be defined. So elements can be nested, as we can see in this case. Entry has sub-elements, keyword and entry text. And elements can also have attributes, like we can see on the register here. So the element name is register, and the attribute name is type, and the attribute content for type is text. And this can be used, and you know that from HTML, for instance, so nothing special here. The elements, of course, consist of a start tag and an end tag. Empty elements can be combined start end tag, look like this. Start and end tags must always be symmetrically nested. If you don't remember how this works, so if I open up entry, I open up keyword, and then I need to first close keyword before I close entry. syntactical error would be opening entry, opening keyword, closing entry, and then closing keyword. So that would be a no-go, and this would mean that the XML file is corrupted. Regarding the names of the elements and the attributes, they can be of any length you want. Of course, it makes no sense to have them extremely long. They are not allowed to contain spaces. They are case sensitive. The funny thing is the initial standard of XML stated that the element names should be small lettered, and nevertheless you can see multiple standards that start with a capital letter. So at some point they ignored that fact and just said, okay, it has no use, everyone is doing whatever he or she wants, so let's do that again. You cannot use XML number or punctuation to start with an element name, but you can use them inside the names. There are different content types for elements. So you have the element content, so elements containing elements. We have the branch thingy. We can have the text content, where you have the leaf equivalent. So we have an element and then some content and nothing else, and the element is closed again. Nevertheless, you can also mix these two. So you can have a start tag, some text, and some sub-elements available as well. And of course, you can have the empty content and then live with that. As we already heard, we have the ability to define attributes. Attributes are key value pairs. So we have a specific attribute key, the key of the attribute, and the value of the attribute. The name, the key can be freely chosen. You have an equals operator, and you have some Anführungszeichen, I don't know the English word, Anführungszeichen, and then the content. And that's basically the idea. You can put the attributes into the start tag of an element or in the empty element. And typically it is used to provide additional information about the elements. The problem with the attributes is that you can only have one type attribute. So you cannot have file type GIF and JPEG and another type equals JPEG. This is not possible. You can only have one type attribute per element. And this is the big setback, whereas you can have multiple sub-elements in file, like when you don't use type as an attribute, but as a sub-element of file, then you can have multiple file XML elements, or as many as you like. So when to use attributes and when to use sub-elements depends on what you want. The advantages of using attributes is that when you use a parser to access the content of an XML file, typically the accessibility of attributes is easier, so it makes your code look nicer. But nevertheless, the disadvantages are also needs to be taken into account, because attributes are not expandable. You can only have one of those per element, which of course makes it less powerful. So the thing is, the code, you only write it once and then you have it done. It depends on the situation. Question?
But an attribute normally can also have a list.
Yeah, of course you can integrate a list. So you could have a GIF, comma, JPEG, comma, TIFF, comma. But then of course you have to split it up manually afterwards.
Yeah.
So, and if you have it stated in different elements, for instance, and you use an automatic parser or you use JAXB automatic conversion, you don't need to manually do something. It can happen automatically. And it depends on how you design it. And of course, it depends on how much effort you want to put into the problem. And this depends on how much time you have available. But different solutions for different situations, as always. And of course, many attributes make the readability of a document difficult. So if you have an element with a dozen or two attributes and they are not nicely arranged below each other, then the readability suffers quite heavily. And you may know that from Android as well. This brings us to another aspect, namely the statement well-formed or valid. This is always a nice exam question. When is an XML file valid and or well-formed? The background is we typically use something that is called a parser to extract the content of a structured document. And in order to be able to use this parser thingy, we must make sure that the content, that the file is stated in the correct manner. And there are different versions of correct. The most basic correct is the well-formed. And when a XML document is well-formed, then it concurs to the standard XML structuring rules. One root element, elements are nested in the correct manner, attributes are not multiply integrated, the attributes are stated correctly, and. So the most basic XML specification is taken into account and is correctly used. And when the XML document does that, it is named well-formed. And it can be even be more well-formed. And when it is more well-formed, then it is valid. So there is an additional mechanism, which we talk about after a short break, that is using a schema specification. And when the document is not only syntactically correct to the XML standard, but also syntactically and semantically correct to a schema specification, then the document is valid. So valid is better than well-formed, but well-formed is already nicer and sound. And that's the idea. This brings us to the schema definition languages, which are able to be used. Nevertheless, we make a very short break, 2 minutes, so we can grab something to drink. And after that, we talk about schema specifications because we are lagging behind and we still have 70 slides to go and we only have 40 minutes to go. So this is quite difficult. So see you in 2 minutes. Okay, back again. Hopefully everyone is back at her or his desk already. We already talked about the ability of XML files being well-formed or valid. And in order to be valid, you need to specify the content and the structure of the XML file in more detail. So well-formed means if you are syntactically correct, you can do anything you want. Every element you can think about, every content, every sorting of the element is possible. But when it comes to parsing the content, automatically parsing it and extracting the content, typically everyone can do whatever she or he wants is not a good solution. So there are mechanisms that define, okay, if you want to exchange this type of content, you need to first provide an ID. Second is you need to provide a type, and the types are A, B, or C. There is no D, there is no E. A, B, C is the only thing that is possible. And in order to state that, there are the schema languages, and the schema languages define, okay, first ID, second type, and then you can do this, and then you can do that. And in order to specify that, the schema languages are used. And of course, there are multiple schema languages available on the market. And the oldest one is the document type definition. And for XML, the most commonly used one is the XML schema. The nice thing about XML schema is that it is also formulated in XML, but basically one thing. So in order to specify the schema that defines how the file should look like, what is allowed and what is forbidden, we typically use XML schema. And if we use the XML schema and provide the definition how it should look like, typically this is conducted in form of another XML document. And this XML document is saved as an XML schema definition, XSD file. So if you stumble upon files with the ending XSD, you know there is a schema specification. The schema specification tells you, okay, how should the elements be named? In which order should the elements be used? What attributes can be used? What is the content for the elements that is allowed? All this can be specified inside the XML schema. And this is still one of the big advantages of XML versus JSON, where there are a schema specification for JSON should also be constructed, but to my knowledge, there is not the one industry standard that should be used. For XML, this is XML schema, and this can be used. Yeah, so what can be said? It's also XML for XML schema. It describes what can be used and how it should be used. It's stored in XSD file. And the XML documents typically have a reference to the XML schema, and you already saw that multiple times in the Android course. When you took a look at the layout description and the manifest file, there are always the XML schema specifications available, but you haven't presumably you haven't recognized that. The root node is schema array, but that's not really the relevant facts. So the XML schema can provide rather simple basic data types, or already provides simple basic data types. And these basic data types can be just like Lego bricks, be used to specify more complex data types. So there are something called simple types, which only contain or may only contain text and have no child elements or attributes. And there are the complex types, which can be way more powerful. So in order to specify something, okay, in my content, there should be a tag that is named language. You could either choose a simple type. So this is a simple type specification where you just say, okay, I have an element which has the name language. So we can state language, and the content of this element is a string. So I could state Italian here as well. If you want to restrict the content here, you cannot use a simple type specification. You need a complex type specification. And this is a complex type specification. You still state that it has an element named language and that it is a string, but then you can specify the restriction for the string that only German, English, and French is allowed. So if I stated Italian here and would deliver this content to my system, the system could say, okay, you provided a false XML document because Italian is not allowed. We came to conclusion that only these three are allowed, and therefore Italian is forbidden. So that's the possibility for the content. Same for a more complex element. So the complex type is a sequence of XML elements which needs to be taken into account in the correct manner. So the person has an ID, has a name, and has a telephone number. And this can be stated in this form. The thing is, when you have a rather complex XML specification, you don't want to do this by hand. So the construction of the XML schema files typically is tool supported. And one typical thing that is also available is that these tools are graphical supported. So you drag rectangles and operators into the screen and adapt the elements. So typically you don't write that by hand. You use a nice editor that provides you with the tools to generate these files based on something that is more nice to use in the real world. The schema documentation, or where to find the schema for the system, is typically defined in something called schema location as an attribute of an XML element. In order to use that, we have to define specific namespaces. And if we want to use schema location, we have to integrate a specific schema in XML schema specification, and then we can use that on the XML file. Due to our timing restrictions, we cannot go into more details here, sadly. One thing that needs to be taken into account is these namespaces, why we should use namespaces in XML. So something that pops up here. So you have an XML namespace and you provide a specific header for this namespace. So you say, I want to have a namespace FIS that has this content. And this VIS can then be used on specific attributes which have been defined in this schema specification, if this would be a schema specification. And this is important because the XML documents and their specifications are often reused in different scenarios and also oftenly mixed. So I use two different specifications in one XML document. And then, of course, it can happen that both specifications, both schema files, provide the same element tag, like, for instance, a point from the SQL schema specification and a point from the geometry specification. And when you use an XML tag with the name point, which one of the both words does it belong to? And then the namespace comes into account. So the point and the SQL schema specifications get their own header tag. And this header tag is then used inside the XML file. Quite equivalent to this tag in Java, for instance, or the package name in front of a class that is specified. And this is something that is important later on if you use multiple specifications. This brings us to parsing. So if we want to exchange the data between the systems, at the receiving side, we get the data, and then we need to somehow get at the content of the data. So we get this information from our communication partner, and we somehow need to fill in the person with the name and the address and the birthday and the address and the social security number and. And this is typically done by something called parsers. And the parsers is a software component that knows the structure of the document and can split it up into useful chunks and extract the content. And internally, it uses something like a string splitting mechanism, but way more sophisticated. So again, in our exercise, we do all the single steps. We first play around with this, cutting the string with the string class. Then we get rid of that, use a parser that does it internally, of course, does the same. It gets the input and splits it into useful pieces. And then we do the third step, doing it in an elegant way. When we use parsers, we typically have two different parser types available. We have the so-called stream-based parsers, and we have the tree-based parsers. The stream-based parsers are at the Java side. Namely, it's the simple API for XML, the ZAX parsers. They are, as the name already states, stream-oriented. So they start at the beginning at the document and then go through the document step by step by step in a stream-based approach. It flows down the document. And it is therefore event-oriented. So when it reads the document from the beginning and it finds something of interest, then it throws an event. I found something, this, and I found the next thing, and I found the next thing, and I found the next thing. And all you need to do is hook yourself to this event queue, and then you are informed, okay, I found the start tag with this name. I found the end tag with this name. I found some content with this content. And then you can hook up into this event handling mechanism and extract the content when the appropriate event is thrown. On the stream-based world, we have two different versions. We have the push-based and the pull-based. The push-based is mainly like you start the process and the process is running and you cannot manipulate it. You are just receiving events. It starts and you get events and you have to process the events. On the pull-based approach is you tell the system, give me the next one. So you are more in control. Give me the next one, give me the next event, give me the next event, and so on, until the whole document is processed. So in the push-based, the parser is the driving force. In the pull-based, your own application is the driving force. It's the two differences, but the document is read in one go, and you just get events, what has been found. A totally different approach are the tree-based approach, which is also known as the document object, the DOM approach. The DOM parsers try to reconstruct the tree-like structure of an XML document inside your computer memory. So it reads the root element, builds a node inside the memory, and then builds some branches and some subnodes and some leaf nodes. So the document is reconstructed inside the memory as a tree. And when the parser is finished, you have the tree inside your system. This, of course, is quite attractive if you want to manipulate the tree and manipulate the XML file. So you can restructure branches, you can prune branches and stuff like that. And then if you have the new structure of the tree, you can serialize it again into an XML document. This is only possible with this tree-based approach. The stream-based approach just gives you found something, found something, found something. It doesn't build anything. So if you want to change something in the XML file, you need the tree-based approach. If you just want the content, you need the stream-based approach. And of course, the stream-based approach is way faster and uses way less memory, because when you build a tree from a file that is a few megabytes big, then you can imagine that the result is even bigger inside your memory. So always be careful when you use this DOM approach on some XML content. So that's the comparison of the two parsers, the stream-based versus the tree-based approach. And of course, the parsers are always integrated in every web service environment. You typically don't see them anymore because they are used in the background. And that's the reason why we at least build one or use one in order to know at least what is happening under the hood. For XML parsing, there are multiple parsers available on the market. And of course, the Java language supports some already built-in ones. And for the exercise, I provide you with the information regarding the stream-based push parsers, where you can use the SAX parser factory to get a new instance of the SAX parser factory. And when you have this parser factory, you can build a new parser. And when you have a new parser, you can tell it to parse a specific XML file. And all you need to do is provide a handler implementation. And this handler then receives the events that have been thrown. So one event would be, okay, I found the start of the document, I found a start element, I found an end element, I found some characters, so some content, and you can use that to extract the data. And this is how it could look like in a code where you can use the stream-based push parser approach. This would be in a matching stream-based push parser handler implementation, which could be used later on. And the same for the stream-based pull parser, quite similar. You get your hands on a parser factory, and then you build something that is able to do the parsing. The naming convention is quite different, which is not really knowledgeable, why they always need to come up with different names. Nevertheless, if you have this parser in your hands, you can query if there is a next element available. So if you can continue with parsing, and if there is a next element available, you can trigger what event is available, and then you can use that. And there are different classes involved, and this is a code fragment that uses a stream-based parser to pass through an XML file. This brings us to what we need in our exercise, namely the most elegant approach parsing this content is not using a parser directly, but indirectly transforming it into an object seemingly automatically. All the magic is done in the background, the parsers that are used in the background. And this on the Java side is called JAX-B. This is the API that is used to convert Java objects into XML and backwards. And it is has been into part of the standard SDK for some time, and it was always part of the enterprise edition. And yeah, it's nice to be used. If we integrate some additional libraries, we can also do the same stuff with the same content, slight adaptation on the marshalling and unmarshalling side, but the data stays the same, and then we can convert it to JSON, which is also part of the exercise. And the official documentation states if we have a schema, we can even based on the schema, let the schema compiler construct some Java classes, which we then can use, or we can automatically use a Java class, which is also already available, annotate that usefully, and then we can convert a Java class into XML and backwards again. This is what we really want to do. So we will build Java JXP mapped classes, and we will be constructing objects based on that. And when we have these objects, we will convert them into some kind of XML documents and backwards again. And the schema aspect is something we ignore in this exercise because it would extend the exercise even more, and we still already have not enough time to solve everything in a nice and easygoing manner. So what are the requirements to do exactly what we want? We want to have a Java object, a Java class that can be transformed into XML by a simple method call. And of course, later on, we want to have an XML, an equivalent would be having an XML document, and we want some Java objects based on that. But we typically we start with version A, Java into XML, and from XML back to Java, and we already have the Java. So what we have is a simple Java object or class, plain old Java object, Pojo, that can be converted into XML. And all we need to do is we have to use some sort of annotations to fine-tune the serialization. An important fact, and this will be an error for some of you, is that this Java class must have a no argument constructor. Otherwise, it will not work. And the error message, the exception thrown, is not as speaking and as many other errors that it can occur. So everything you want to serialize and deserialize using JXP must have a public no argument constructor. Otherwise, it will not work. Keep that in mind. So our goal is to have a dummy class and fill that with data, and then convert it in a very simple, very elegant way into XML, communicate that XML to some distant computer, receive the XML, and build a Java object or a C++ object back from based on this information. In our exercise, we stick to Java. This is our goal. In order to do that, we have to annotate this plain old Java class here. And the annotations we want to use is, first of all, we need an XML root element that states, okay, this is the root of our XML file. For these annotations, we again have the possibility to manipulate or fine-tune the behavior. So if we are not happy with dummy data, we could, and there is a typo in there, we could change the name of the XML element by using the name and by providing, for instance, a new namespace. It could also be used here. So this is possible to manipulate the XML root element with the help of this attributes for the annotations, or parameters for the annotations. So that is possible. Aside from the root element, we can specify which XML element and define exactly what elements should be integrated into our content data. As you can see, this looks like that. We can also specify that certain elements should not be handled as XML elements. This has been done here. So M data is a sub-element of dummy data of the root. And if we use XML attribute instead, it's not integrated as an sub-element. It is integrated as a specific attribute for the element that is its parent container. So we can manipulate that. Another thing that needs to be taken into account is the availability of arrays and lists. So when we have a list of data, we typically want to have a enclosing branch. And in order to have this enclosing branch, we can use the annotation XML element wrapper, which wraps the list based on a specific, okay, now follows a list of data elements. And this can be stated in this form here. And then, as you can see, you can specify the name of the wrapper bracket, if you want to call it a bracket. Aside from that, you can play around with the XML type, where you can specify the order of the properties. So in which order should the XML elements be specified. You can also play around with the XML accessor type, which is a macro where you can just say, okay, every field, non-static, non-transient field will automatically bound to XML. So you don't need to, if you have multiple entries, as we have with dummy data, we need to specify, okay, XML element for M data A, and XML element for M data B, and XML data for element C. So we need to integrate rather a few annotations. If you don't want that and you want all of them to be part of the XML content, you can use this XML accessor type field, and then every property in the class will automatically be bound to XML. So you can play around with that. And so you could either go for the properties that are non-static and non-transient to be automatically integrated, or if you have getter setters, then you can use the property and it will check if there is a specific getter setter pair for a specific property. And if there is a getter setter, it will be integrated into the XML output. And if it is not, it's not part of the output. So that's basically the idea of the annotations. And the exercise will be playing around with quite a few of those. Accessor type, I think, is not part of the game, but XML type property order is something you have to play around with. XML element wrapper is something you have to play around with. XML attribute is something you have to play around with. And XML element is also, especially namespace, is also something you have to play around with. So all of them, aside from XML accessor type, are part of the exercise. So you have to use them later on. What libraries are necessary to play around with JAX-B? Before version 11, not a single one, because everything was integrated. After and with version 11, quite a few need to be integrated. And as I already stated in the when we would be doing this together in the lecture room, you would have to manually download them and incorporate them, and you could download them from the Maven repository. And in order to give you the impression how gruesome it is to do it manually, and later on you will use just a build tool and it happens automatically, and then you know why you always want to use a build tool for your projects, especially when you have lots of external libraries involved. But as we don't have this luxury, you can just use the packages available on the Moodle platform. So what do we need to convert or to use this JAX-B approach? What we need is we need a JAX-B context, and the JAX-B context can be extracted by calling the new instance method call. When we use this new instance method call, we always have to provide the target classes we want to use during serialization and deserialization. You will see that later on in the code examples. Once we have a JAX-B context in our hands, we can create a marshaller and we can create an unmarshaller. And as you already know, marshaller converts the object into the transport format, XML, and the unmarshaller uses the transport format and generates an object out of it. So a marshaller builds XML data, and unmarshaller reads XML data and builds an object. When we have the marshaller, we use the marshal method to convert the XML stuff into the string output. This is necessary. This is something we want to do. And of course, we can fine-tune the behavior of the marshaller by setting specific properties. Especially the formatted output property is important, because otherwise you get everything in one row, which is totally okay for a computer, but for humans it's hard to read. So the JAX-B formatted output is something you really want to use. And if you don't have a fully fledged XML file, just a fragment of an XML file, and in our exercise, in the second exercise, we will use a fragment of an XML or JSON file that contains the weather information for a city we targeted, and we don't need the whole weather information. We just need a tiny fragment out of it. And therefore, we are already playing around with this. I have a fragmented part of a decent XML file, and then we need this property here. Same goes for the unmarshaller. Some XML input goes in and some objects pop out. The thing is, the more complex it gets, the less this method works. Later on, you will see, and it's already stated in the exercise sheet for Thursday and next week, we typically use this method, unmarshal. We define, okay, this is the XML input, and we want this type of class to be popped out of it. So it already knows which is the target class. This will definitely be used later on. In the beginning, this simple approach also works, but the more complex the structures get, the less this works and the more we have to use this one. Stream source is something we can use. We have to use JAX-B elements, but you will see the use of these classes in the exercise snippets. So in scenario A, let's take a look how this works in code. Everything is normal. We have a Java object, we convert it into XML, and we convert it back to an object. In scenario B, we have multiple elements of a certain type need to be processed. So we have a set of objects and want to convert them to XML and later back and there is B1 brute force. We ignore the rules of XML, and B2 is how it should be done. So what we need is a class that is usefully annotated. Keep in mind, we don't really need this field thingy here on top because we annotated all the elements by hand. And as you can see, I want the name of the XML element to be slightly different than the name of the variable because of the different naming conventions. We have a public zero argument default constructor, and we can use that. So in order for the marshalling and unmarshalling, I built myself a sensor value based on the content. I get myself a JAX-B context. And as you can see, I already define, okay, this JAX-B context should be relevant to the sensor value class. Then I create myself an unmarshaller, manipulate the output of the marshaller that the output should be formatted correctly. So human readable support. I built myself a string writer. Then I use the input, my sensor value, and let the marshaller print everything out into the string writer. Then I can use the string writer, get its buffer, convert it to string, and then data contains the XML. So I can print out the XML and take a look at it, and it looks beautiful. And then I use the JAX-B context to create an unmarshaller, and then use the unmarshaller to generate a sensor value. This is the simple implementation, and on the exercise sheet you see an example where this other unmarshal method mechanism is used. And then I can print out the resource again. And the output would be something like this. So everything nice and sound. So second scenario was I have a list of sensor values and I want to convert them. At this point, we only have a sensor value. The sensor value class is annotated for JAX-B. So in order to serialize it, I just use a queue to go through the elements and marshal them all one by one. The problem, of course, is this would be the output. And the output is two declarations, which of course is a bad syntactical mistake. And of course, we don't have a root, which is another syntactical mistake. So this brute force approach provides us with an errorless approach. This brings us to another property which we can use. We can tell the system, okay, we are just managing a fragment of XML, and then this output would be generated, which isn't syntactically correct in total, but it's not as faulty as the other one. So the declaration is not provided, but we don't have a root element available. And in order to get a root element available, we have to also provide a container class. So we provide a container class, sensor values, which is used and which provides the sensor values, which then leads to the solution that we again have multiple sensor values and then provide them into the system and marshal them way out. And then we get a decent output for that. So taking a look at our clock, we are already over time, but I would like to still show you the JSON stuff, at least to the point where you can use the Moxie libraries. Is that okay for everyone, or is someone having a different other meeting during our exercise break?
We still have 5 minutes more.
Still have 5 minutes more. Perfect. So 25. So this brings us to JSON, JavaScript object notation. As we are already building up are using lots of web technology. JSON, of course, is way on the web world way more attractive than XML because we can convert it into JavaScript with not much effort, and therefore JSON is also something we use or tend to use to exchange data. The construction of the JSON file is available on the slides, but we will not talk about those. I think most of you will have already used JSON at some point in school. So, and if not, it's not really magic. It's just the construction of how to do that, and JavaScript and JSON are quite looking alike, and the conversion from JSON to JavaScript is that easy. And nicely enough, the conversion between JSON and Kotlin is also quite easy if you have the right library available. And sadly, on the Java side, it's not as easy as in Kotlin. What we need is we need additional libraries that are slightly more, not as nice as the Kotlin world. One thing at least that is nicer in Kotlin than in Java. So what we want to use, and of course there are multiple ways to convert a Java object into JSON, but we want to use the Eclipse Link Moxie library, which is part of the open source Java persistence solution. And this pack of libraries enable us to convert a Java object into XML or JSON with just minor changes of the properties of the marshaller and unmarshaller. So this is rather nice to be used. Of course, we need, again, some additional libraries, and these, of course, are not integrated or were never integrated into the JDK because they are a different side branch. And what we need is the Eclipse Link and the Jakarta JSON libraries, which can be downloaded again. But as I said, I have provided you with a package in the Moodle library, which you just have to integrate into your project, and then everything should be running smoothly. The nice thing about Moxie is that we have some kind of marshaller properties and unmarshaller properties, which provide some constants, which we then can use inside our code to work with that. We also have this fragment aspect, but it's slightly differently called. So if we have this include root or not is similar. And depending on what version you have, this is something which will be quite interesting to see. We might need a so-called JAXB property file inside your content classes directory, which tell the system which context factory to be used. Or you can use this piece of code in front of the construction of the context. So that before you construct the JAXB context, you have to state this, integrate this piece of code, and then you should be able to discard this JAXB properties file inside your project. But we will see how this evolves during the exercise construction. Again, using Moxie, we have different scenarios. Scenario A, everything is normal, object to JSON, JSON to object. Scenario B, root element is missing, JSON to object, and backwards again. Scenario C, brute force, multiple elements. So basically the same setup, or at least slightly similar setup to the last thing. We again will try to manipulate or serialize our sensor value. And as you can see, we use the exact same sensor value class. So no new annotations are necessary. Everything can stay as it is. all we need to do is we need to manipulate the file that does the marshalling and the unmarshalling, because we of course have different JAXB context and marshaller classes with different package names because they are residing in different libraries. Nevertheless, the code nearly looks identical. Merely the property setting is slightly different. So what we can see is we set another marshaller property and set it to JSON. And then this marshaller automatically converts the test sensor value into JSON file. And if we would state it here, application XML, then data would be an XML file. So we just have to manipulate the content of this property, and then this conversion object to XML and object to JSON is done automatically. And of course, the other way around. The property formatted output stays the same. So all we need to do is use different libraries and integrate, of course, recompile our classes, change the imports and integrate these two lines of code. And then our system is capable of converting our object into a JSON object and backwards again. Nothing necessary. So scenario B, we have a missing root information. And when we want to tackle this problem, we have to, again, slightly manipulate the unmarshalling. And as I already stated in the XML file, this will be the case when we play around with the SOAP web services, because we will trigger a weather SOAP web service somewhere in the net, which provides us with the weather information for every city we want. And it provides this information either in XML or in JSON. And depending on which output format you choose, you either have to use this fragment XML approach or what is stated here, the missing root information for JSON. Or you convert all the data into one Java object, which is not necessary. You can cut the relevant part out of this provided JSON content. If you cut out the information from the overall surrounding, you have to set the JSON include root to false. Then you can stream this element. And again, here you can see the different unmarshaller, where we say, okay, we unmarshal the stream and hard code which is the result, because it has no root and therefore it cannot identify, okay, which target class should be used. And then I can extract that. So this is a very important slide for the second exercise, playing around with the weather service and when you are playing around with JSON as a result content. The same thing, we have two sensor values and a container class, brute force approach. Of course, this is a not nice JSON file. So we again choose to annotate the sensor values as well. And when we annotate the sensor values, we get a nice sound output for the content. And this brings us to an end of this lecture. And I'm sorry that it was so fast, but lots of content and you have to do the exercise. And therefore, we have to get through it all in one go. So I will close this session in a second or two, a minute or two, and open up the exercise conversations, and then you can join me there. Okay, so see you later. Bye.